Hi there, welcome to another video from Hegarty Maths. It's our second video on counting sets using Venn diagrams. So let's start where we ended on the previous video. We did questions like this. Pause the video and double check you can answer these questions. Okay, here are the answers. And this was a case where the Venn diagram counts the elements in the set and you just had to use logic to answer the following 4 questions. So if you can't do that, make sure you can go back to the skills prior to this and learn those techniques. Now in this video we're going to use Venn diagrams to solve problems in context of counting sets. So let's get straight into it and deal with some worded problems and draw in Venn diagrams to represent them. Okay, here's the first one. Pause the video and have a go. So in a class it tells us that 5 played the flute and the piano. It says that 9 played the flute only, and it says that 8 play the piano only, and 11 play neither instrument. How many pupils are there in the class? A Venn diagram will work here because the options are with your students: they play the flute, they play the piano, they play both, or they play neither. So there are options there that can be drawn in a Venn diagram. Let's draw a Venn diagram here. Let's let this one here represent the flute, so F, and this one here, let's write P to represent the piano. And let's go through the facts. 5 play the flute and piano, so 5 must go in the intersection here. 9 play the flute only, so 9 must go over here. Then, and tick that off. 8 play the piano only, so 8 must go over here, and 11 play neither instrument, so 11 must go outside. It asks us how many pupils in the class, in other words, how many elements in the universal set. So in the universal set we have 9, add 5, add 8, add 11, like that. And you get yourself the answer 33 here. So let's state the answer, 33 pupils, and we're done. Okay, next one, pause the video, have a go. Right, we can draw a Venn diagram as before, and let's use the facts to fill it in. In a class of 40 pupils, so the universal set is equal to 40 pupils. It tells us that 9 play the flute only. Let's label this F, let's label this P for piano. 9 must go here. 8 play the piano only, 8 must go here. 11 play neither, 11 must go here. The only factor we don't know is the intersection, which we'll label as X. It asks us how many pupils played the flute and piano, i.e. what is the value of X. Well, we know for sure that if we do 9 add X add 8 add 11, it must add up to the total number of pupils, which is equal to 40. That gives us that X add 28, combining like terms, is equal to 40, and subtracting 28 off both sides, X therefore must be equal to 12, and we're done. So how many pupils study the flute and piano? You would say 12 pupils. Next one. Pause the video, have a go. Okay, similar scenario here. We can draw a Venn diagram. Let's label it up. Let's call this flute. Let's call this piano. Let's go through our facts. In a class of 42 pupils, so the universal set is 42. 9 play the flute only. Let's put 9 here. 8 play the piano only. Let's put 8 here. 11 play both, so 11 goes here. How many pupils play neither the flute nor the piano? The only thing we don't know is X outside here, but we do know if we add up 9, 11, 8 and X, we must add to 42. So 9 plus 11 plus 8 add X must equal 42. Alright, that gives us, combining like terms, X add 28 is equal to 42. Subtracting 28 off both sides, X must be 14. So X is 14 there. How many pupils play neither the flute nor piano? Therefore we must have 14 pupils, and we're done. Next one. Pause the video, have a go. Okay, here we can draw a Venn diagram again because we've got a scenario where there's 120 bags and they either have buttons or zips or neither or various combinations. So let's draw a Venn diagram. Let's have this as B for buttons and Z for zips. It tells us the company makes 120 bags, so the universal set has 120 elements. 32 of the bags have buttons but no zips. So let's put 32 in here for the buttons outside the zip region. 20 of the bags have zips but no buttons, so 20 must go here. It says 13 of the bags have neither zips nor buttons, so 13 must go out here. The only thing we don't know is this value here. Now the question asks us how many bags have zips on them. So it doesn't ask us to find x, but we're going to need x to work that out. So let's write an equation down. We know for sure that if we add 32, add x, add 20, add this 13, it must add up to 120. Okay, so if you add that up, 32 add 20 is 52, add another 13 is going to be 65. So x add 65 is equal 120. Subtracting 65 of both sides, you get yourself that x must equal 55. So 55 goes in here. Now that wasn't the question. The question is how many bags have zips on them. Remember, zips would be everything in this shaded region here. So it's the 55, add the 20, which is going to be equal to 75. So we just state 75 bags, and we're done. Okay, next one, pause the video, have a go. Right here, we've got students who study art, biology, a combination of both or neither. So we've got 45 students, so our universal set is 45. Let's label this A for art and this B for biology. It says 7 study both art and biology. 7 must go in the intersection. 8 study biology but not art. 8 must go over here. 13 study neither subject. 13 must go here. The only thing we don't know is how many study art but not biology. It says find the number of students who study art. The one thing we do know is this unknown value here. If we do x, add 7, add 8, add 13, it must add up to how many elements in the universal set, which is equal to 45. So therefore x add, combining like terms, 28 must equal 45. And then subtracting 28 from both sides, you get yourself that x must be 17. So x is 17 like that. Now that wasn't the question. The question was find the number of students who study art. That is everyone inside this circle, i.e. that's 17. Add that 7. So it's going to be 24 students. And we're done. Okay, next one. Pause the video and have a go at this. Right, this one's a little bit trickier. Let's think through it. It says 100 people are applying for a job. So that sounds like our universal set is 100. It says 22 people can speak German, not Spanish. 16 can speak Spanish, not German. The number of people who can not speak German nor Spanish is 12 more than the number of people who can speak both. How many people can speak both? Let's draw a Venn diagram. Let's label this here as G for German and this here as S for Spanish. Now, 22 people can speak German but not Spanish. 22 must go here. And we've used that fact. 16 people can speak Spanish but not German. 16 must go here, and we've used that fact. It says the number of people who cannot speak German nor Spanish is 12 more, and this is key, is 12 more than the number of people who can speak both. So we don't know how many can speak both, but let's call it X. And then it says the number of people who cannot speak German or Spanish, how many people outside here, is 12 more than this. So we're going to call this x add 12 here, right? Now the one thing we do know is if we add all these together, they must add up to 100, and we can use that fact here and write ourselves an equation. So we can state that 22 add x, add 16, add x, add 12 must add up to 100. Now collecting like terms, we're going to have 2x here, and that add that is going to be equal to 38, add that is going to be equal to 50. So we get 2x add 50 is equal to 100. Subtract 50 from both sides, 2x must be 50. Divide both sides by 2, it tells us that x must be 25. So we know for sure therefore that this is 25, and this here must be 25 add 12, which is equal to 37. Now the question said how many people can speak both? It's 25. So 25 people, and we're done. And that's it for this particular video. Thanks for watching.